So first of our FDP syllabus, so we have covered that C programming and then CAN protocol and then development of CAN matrix. So we just focused on now this RKE, BC discussion and then RKE to BC mapping. So for the CAN TX and then RX programming and then message response programming. Okay. So further we will take the help of our real-time coders to transmit some values and then based on the values it is going to respond some values. Okay, so by the help of this Arduino and then TX master, we will see the transmit and then receiving it. Okay. Okay, so now we can discuss about this RK and then BCM. So the RK is nothing but the remote keyless entry. So the remote keyless entry ECU or its node, we can call as a remote keyless entry ECU or node. Okay, so this remote keyless entry has some different kind of features. So like, so the remote keyless entry means we can mention like a key fob. So without that, we don't need to open the or using the real-time key to turn opening and then close like that. So instead of that, we are having some button features. So one button for the lock feature, one button for unlock feature, one button for the open features. So and then the same buttons having some different kind of features also. So if you are holding the unlock button for more than 3 seconds, means it will be opening that search alarm. Or else whenever you are inside of the door, the ignition will be turned on. At that time you are pressing the unlock button for more than 10 seconds, means panic alarm will be enabled. So at the time of the beep alarm will be beep sound will be enabled for if you are not enable the seatbelt or if your doors are open there. So at that time you just press the unlock button inside of the car, means the mute that is going for the unmute. Sorry, mute beep off enabled. So these kind of different features are available. Now we can just discuss about only 3 features. That is easy for learning that RK easy. So lock, unlock, tailgate. So whenever you are pressing the button, so it is going to check all the, for example, lock button, it is going to check all the 4 door values. So now the 4 doors are in open mode or closed mode. So whenever it is getting all the doors and closed mode, we are able to lock the door. So if it is any of the door is open, means we are not able to lock the door. The same concept as we discussed in C programming. So the same concept we are going to execute with a real-time orders. So here the block file we are going to generate with our real-time bit. So we are having all of test bits of 3 ECUs. So now we are going to just work with the two people and the 2 ECUs. One is RK ECU, one more is a BCM ECU. So now RK ECU going to send the value of lock button, means the BCM will check all the door values. Suppose the doors are in the lock closed mode, means the BCM going to respond like that. For example, here we can turn on left indicator. Okay, for like a locked condition, we can take the left indicator. So in the database, I have only. So I just open our CAN BTC. I should open a CAN BTC what I have shared. So just open BC. Okay, this BCM carrying the different kind of signals like high beam, low beam, left indicator, right indicator, bar page status only. So I am not mentioning any lock or unlock values here. Okay, so instead of that we can take the help of left indicator, right indicator. Okay, so for example now the lock condition is satisfied and it's enabled, means we will get the output by left indicator turn on. Okay, so if the unlock condition is satisfied, whenever we are pressing the button, the condition is satisfied, it is giving the output, means we can take the help of right indicator will turn on. So for the tailgate we can take it as a low beam lamp. Okay, so the 3 outputs we are having now. So based on this condition, these values we are going to set in in our Arduino programming, which is scan RX programming. So based on the request values, it is going to checking some condition. The condition is passed means these are the condition needs to turn on. So suppose the conditions are failed means these are the conditions now need to turn on. Okay. So I will mention here log means left indicator, unlock means right indicator, tail means low in lamp. So now how we are going to set these values? So now we are at the TX code, which means scan write code in our Arduino programming. We are able to transmit the message. So on the message we are having access in the byte version from on the tailgate, correct? So on that you can manually put in the values like 1, 0, 1. So 1 means the log is going to 1. So based on that value, now PC is going to check this messages comes in the PC. So now it is fully comes in the read value, which means whatever we have write, based on the value it is going to read it. So what is the message is sending the values of byte 1, byte 2, byte 3. Okay.
So as we are having 3 Arduinos.
Yes.
So can I use one Arduino with one system?
Yes, possible. Yes.
But we don't have this peak connection.
The peak, as I clarify that, we are able to transmit the different systems by one Arduino for one transmit to the PC, but another Arduino for another PC. But the peak system we are able to connect to only one PC at the time. We are not able to see whether same type of 2 or more than one PCs. Okay, so because it is having only one ender, the USB which end we can connect to which PC, that PC only able to receive all kind of messages. But it is an interface in between the inside the box will be interconnected. Okay, so here in this system we are able to see by Arduino serial monitor. So whatever the value transmitted by one PC, so another PC able to read it by serial monitor, not by TS monitor.
But generally FDP solve, make 2 Arduinos are communicating and it has been displayed data to Arduino what you have transmitted the day before. So like if data system is transmitting or receiving, so they are intercommunicating.
Yes, ma'am. So
it has to reflect in TS master.
in TS master, which means single system TS master we can see. For example, now peak is connected in this system means. So what are changes placed on that system, that values we can see here. Okay, but we are not able to see open the TS master on that system. That is not possible.
Okay, only Arduino.
Arduino interface only we are able to see there. So, but what are the changes we got to read here? That same values we can see which connection is we have enabled with the PC of each USB. Okay. Okay. So now our work is going to work with the 2 programs. Arduino write with Arduino read. So 2 programs we are going to consider. So first of all, I will explain what is read program. After we are going for the merging of read and write. Okay. So yesterday we saw that the write program only, right? So just to open that Arduino, same as go to file. This top left you are having option as file. Just click on this. We are having the option as examples. Open the examples. Go for output WPMC custom library. Open can read. Okay, yesterday we worked with the can write. So now we are going to can read. Yes. So now the can read program is the inbuilt one. So first we understood this program. Afterwards we have just worked with both can write and read. So I will explain this code step by step. The same concept what we installed, which means included in our write program, serial filter interface. Same we are going to work with MCP2 interface. So 2 vector fields we added here. So here we are using the can structure frame of can message. We are adding only one variable here. So I will explain why we add only one variable. So the MCP2 is a chip select number. So if you are working with Arduino, you know means you can using the chip select of 10. Arduino Mega 2560 means select the chip select of pin number is 53. Okay. So don't forget to that because which board you are connected Mega means don't forget to change it is a pin number of 53. If you are working with Arduino means no need to change the pin number. Okay. So second law. Yes sir. For mega 50. Chip select 50. 53. 5. Okay. So on the next one is the serial reading for the serial monitor value reading. Okay. So what are the values we need to read in serial monitor? So bought based on the reading setting here. So next one the common setup MCB reset, set bit rate and then set normal mode. The set bit rate you can change to 500 kbps. So what you mentioned in the right code, the same model we are need to read put in the read code also. So 500 kbps.
The model of chip is also same that MCB 2515. The same model we have to write here.
No ma'am, this set bit rate model mentioned like a can speed. So in our can product I mentioned speed of 126.
Serial dot reading.
Yes ma'am. So this is for serial monitor. So for example, I open the serial monitor. So whenever we are connected here, this bottom right side we are having the baud rate. So now you can give here 9600 also. Now this bottom baud rate we are having here. Based on that we can add it.
If we dump it to Arduino, the Arduino MCB, the baud rate of chip should match with this line.
MCB is the baud rate of?
Arduino is having some baud rate.
Yes ma'am.
It should be matched with the serial baud rate.
No ma'am. There is the serial begin baud rate is not interface with our MCB.
Only if we
This is baud rate only for this Arduino interface only, not for our MCB. So MCP you can set as a 500 kbps and then comma MCP underscore 8 megahertz. This is for our oscillator frequency. So underscore. Okay. So MCP underscore 8 megahertz for oscillator frequency range from our real-time hardware to our TS master tool. Okay.
So MCP 2515 is a controller.
Sir.
MCP 2515.
Yes sir.
Is that
Can model, that can model. Yes. So we are having that reset all the functions before. Afterwards we can set the bit rate as a 500 kbps and then mention the oscillator frequency range. Afterwards set the normal mode. So because we are going to work with normal mode only. Okay. So this serial print it is nothing but the markings we can add it. So it is showing like what are the values going to printed here. First one ID, next is DLC, next is data. So that we are going to read the values. So that it can mention. So don't forget what are the code we are writing the void setup. It will be run only one time only. Okay, so it will not run the loop mode. It is run only one time. So that the setup is only they mentioned here. Okay. So next one void loop. So it is asking for if MCP2515.read message. Yesterday we set MCP2515.write message. Correct. So send a message instead of now we are using the read message. To reading all the values and stored to the can message of structure. So that here we mentioned the can message variable. So ampersand symbol is mentioned like the address of can message. So what are the values you will read here? You just store on this variable. So using our scanf. In the scanf we are using that double quotes %d comma ampersand symbol of a b c something. So same like that we have initially mentioned structure variable. In the structure variable we store the entire message. So this is equal to MCP is nothing but it is asking for the MCP message comes under error or not. If the messages comes with TX error means we will not get any output here. Okay. For that purpose they are using MCP double colon error okay. Okay. So this line is not mandatory. So instead of that you can write like so this is also enough. Got the point?
What is the explain?
I will explain. So initially it is showing like a if and then MCP message and then store into the some of the variable equal to MCP double colon of error okay. So this line mentioned as it is checking the messages comes under the error message or not. So this line mentioned this MCP colon and the error case mentioned like that. It is having error or not. The TX message having the error or not. Error means nothing but in the database we are mapping with some overlapping values, or else the transmitter side is sent with some overlapped values like that. So that kind of value we receive or not. So for that application they are using. So instead of that, if you are getting confused, this line means you are not just you can copy this MCP read message only. MCP dot read message and instead of can message, you will put it under using semicolon. Okay. So this line shows that so whatever message is coming from transmitter side, it is ready to receive. It is not checking is there any error or not. Okay. Got it? So and then you can just close the which means last brackets also because we are using the if case now. So using the open bracket close bracket. So last one bracket we can close. Okay. So next line it is showing to print the can message ID. So this line is for so what is the message received here? Can ID will be printed by XR value after giving some space. So can DLC will be printed here after giving some space. Okay. So from this transmitter side, we will be able to receive by can ID, can DLC, and then can data. So for the help of can for loop, they are getting that can data also. So I will explain. So int I is equal to 0 means nothing but this we can start with the byte of 0. Byte 0, which means first byte has comes and the index value of 0, 1, 2, 3. So that can message the data of 5. So here I comes with the 0. So first byte 1 value will be printed, next byte 2, next byte 3. So based on the DLC value. Now the DLC is 8 means it is taking for up to 7. So for example DLC is 3 means it is taking for up to 0, 1, 2. So what are the values are there? It will be printed here. So this is the can read message. You don't need to change any code here. You just checking this is a code means pin number 10 or else mega code means pin number 53. So second thing you can set the bitrate as a can 500 kbps and then MCP 8 MHz. If you are not changing this code, which means you are not commenting this line also not an issue. It is just like a one line checking the error or not. Okay. Suppose this line not comfortable for you, which means not understandable means you just copy paste. You can read the message afterwards, print what the message you read. Okay. So this is the read message. Now what you can do means open one more tab. Go to file, top up to file. Okay. Go to examples, and then open the write message. Can write. So now you are team means that is a fine thing, or else you need to open two tabs in our signal system. In your team or work daily? Daily. Okay. So nothing but I think in your case also having two ordinals. One. Okay. And then sir, you have
Sir, you are just you are using this kit. Please use this kit. This kit will.
I said you can just sit here. You can take your laptop. One code you can send it by your laptop. One more code you can send it by your PC. Okay. From this
Oh, sensor.
no sir, they are having two ordinals. Just USB USB. Or USB or Okay.
means 10 we cannot do, right?
Yes, instead of that we can do the 50. So the initial equation. Okay. So for this kit, for example, now star need to give chip number as a 53 because we are going to connect as a mega board. The same like that we have now. Same like that for you, sir. Okay. 53. Okay. Okay. No. Wait a minute. I will explain. So whenever I can say to upload that, at the time you just cross check it. Okay. So now we are going to do the one as a transmitter, one more as a receiver. Okay. So the right side persons are going to transmit the values, the left side persons are going to receive the values. You can understand. Okay. So the DNO boards are going to transmit, mega boards are going to receive. Okay. For example, first I will explain for the right code. So which means boards, right side peoples. Okay. You can just going to transmit by this, open the right code. Okay. You don't need to open both the read and write. You just open the right code and then give the values as a chip number as a 10. Now we are going to transmit only one message. Our message ID is RK only. So I can just remove the structure of second one and then remove the structure of transmission. So here our transmission ID is RK ID number is 120. So in this CAN ID you can change this as 0x120. So CAN ID you can change this as 0x120. So then it is having only 3 signals, which means 3 DLC. So you can change the DLC as a 3. Okay. So and then remove the remaining values. So up to 0, 1 you can have it. Okay. So now you put these all values in the void setup. So but we know it in the void setup we can give inside of the loop. Why I am saying this inside of the loop means we are able to change the values as per the user input. Okay, now we are going to flash the values only. But after I will explain how to give the user input. Okay. So now what you can do is just to copy this message ID to DLC and then everything. Just using the control X and paste it on the inside of the loop. Now if you got this, like
ID also you want to
sir.
ID also you want to
Little but just I mentioned that we can add.
remember ID DLC.
Not DLC no need to give the loop. But if I just focusing on data only. So data only is going to vary. Like it is like off value, it is like unlock value, so 0 1. So for our understanding, I am using command line to mention this. So after creating the ID number 120 and then adding the DLC of 3, so instead of the values, we can give the value as 1 as 1, next one as a 0, next one as a 1. So you can give any values. 0 1 any value you can give it. That's not an issue. Okay. So afterwards, you just using only MCP send message of 1. Here it is having 2 messages. You just delete one. Just the MCP 215 dot send message. Okay. So now you just select the board, which means you can connect the USB port. Means you will get the what are the boards now you connected. You just select the board and then go to the board. For example, the port number which one you have it. So open the board and say you know. So select this Arduino you. Okay.
Yes.
Now you got it. You don't need to upload it. You are going for the okay. So after selecting the board, click OK, then check verify and then go with the uploading, done uploading. Okay. Yes. That's all. Now code uploaded from the transmitter side.
Yes.
Yes. Okay. So next for the receiver end. Okay. So just you have opened the read code. Yes. File examples. Auto MCP and then read code. Already opened means you can just open that at the same time. Okay. So in this read code, maximum you have the mega code. So initially change the MCP pin number as 53. Okay, so change the pin number as 53. Check the baud rate as a 500 kbps and then MCP in hertz.
This is Arduino. This is Mega.
Yes, madam.
This is Mega.
Yes.
So I have only K.
Yes. Okay. We need to change the pin number 53. Okay. So and then set bitrate as a CAN 500 kbps and then comma MCP in hertz. Okay. You change it means again you can select the board. So you can connect the board. So then getting the selection of board, click and then select the type was a mega. If you type mega means you will pick the mega or mega 2560. Okay. You just select the board and then click OK and then click upload. One more as a receiver. So whatever the values we are getting from the transmitter, the same thing we can see by the receiver. So now we are going to checking the values. Now we are just receiving the values. So apart from means it is going to set the body control model output left indicator as 1. Okay. Because now we don't have any door values now. So instead of that, I will directly give you the output. Okay. So I will write that. Okay. So now this receiver FDP we are receiving the ID number 120. It is a serial bit monitor only, but it is not checking any conditions. So now we are using this place this rate message. We can check. First we can print all the values. After that we can write on the if statement. If we can store the can message ID, can message. So can message dot can ID is equal to 0x120 or 1. We can check in the condition. Suppose the condition satisfied means we can give one more if.
Okay.
If can message dot can data of 0 is equal to 1 or not. Like that. If the condition satisfied, we can set the we are going to write the message. Which means you can take one more variable can message 1 dot can ID is equal to 0x13. For example, body control model equal to 13. So you can set the value. Afterwards, you can set the can message 1 dot data of, which means now the left indicator like another third bit. Third bit means that right means you can take as 2.
No, ID.
So the ID for PCM. Now we are going to write the message. Suppose this condition satisfied, you are going to set the left indicator to turn on. So you can set the value as 1 here. Afterwards you can write the MCP2515 dot write send message. Send the message of ampersand that can message 1. I think we can answer. We can check that from right to so if satisfied means we can write like this. So it is if it's a we can use 3 for one is for first bit. So it will be else for second bit. So third for third bit. So afterwards you can just say line number 13, but we are accessing the data of 2 for this is for identity. For identity it is line number 5th bit. So you can say data of 4. Okay. We can modify it. So now this coding is reading some values, which means this one for example now the body control model is receiving the RKA values. The RKA values right now 120 is not, it is checking. So now it is confirmed means it is checking the byte values. The first bit is lock value. So based on the lock value, it is going to generate the left indicator turn on or turn off. Like that.
So only this one is done by read.
Read bit.
So write people only just
So yes, right, we just generate the values, but you both are just compare and work it and you can write more. Okay.
so whatever was in the read is in connectivity is also in this also.
Yes. So now we can connect this after uploading this code. Once you write this code like if conditions, after you connect that and then open one panel and then add left indicator, which means IC left indicator. Received by IC now. You can add it means
This will be C.
IC. Received by not it is transmitted by DC. Yes, because based on the value, now PC is going to transmit the value 1 or 0. So that 1 or 0 is your external measure. Now the values we are setting for actuators. We don't know the actuator, which means that LED. So instead of getting actuator, we can set the LED output. We don't know the LED. Instead of another receiver as IC. So the IC we can see when TS model. So that is the final stage. So when we complete this coding, after we can move to TS model checking this condition is working or not. Okay. Now you got the point.
C.
I am saying P, which means nothing but What we have right code. You can take the type of right code controller.
Wait, how to say this code is we have to write it the transmitted pattern.
Received background. Receiver side. I just explained from scratch answer. So now the right side people are going to transmit the RK messages. ID number 120, the value of 1 or 0 like that from right side people. So now the left side people are going to receive the values. So this is our receive values. This is our receive value. So here what I am saying means you are just printing the values. Instead of printing this
MCP2515.
MCP2515 dot send message.
Send message.
Yes, in this right code, I will just explain right code. So here you have created a message ID number 120 and then the DLC of 3 and the values you set it. And then after setting you can just send in the MCP to send message. Now same just you can do the copy and then paste here. So for example I can say afterwards here you can using if so that can message ID. Can message ID is equal to 0x 120 means you can check the first byte. So the byte value we can check it by the data. Control C. If the can data of 1, sorry, which means first byte is 0. The value is equal to 1 means you can write only if else. Like the value is 1 means now you can set it the left indicator turn on. So the left indicator means we can see in our cam DB. Okay, so this is the body control model message. So the ID number 70. Now we are going to transmit the ID number 70 where the left indicator located means. So the left indicator located on 5th byte. The left indicator located on the 5th byte. Okay, so the 5th byte means you can write the code in. So ID number 70. So the DLC no needed. So if you want means you can add it because the DLC is having 8. So it is the 5th byte means the number of index is 4. So you can set the value as a 1. So after setting you can write the MCP can message of 1. Okay. So this is what I just mentioned here. So before that, this variable you need to mention on the top. So here you mention the can message 1 only. So you just copy this structure and then give the variable number as can message 1. So this can message, first can message is going to checking the values of receiver, which means transmitter. So what is the value for example ID number 120 or whatever you are transmitter, it is the value stored on can message. So after receiving this can message, it is going to checking the condition in the void mode. I just remove this kind of lines. Okay. So now the MCP going to read the message. So whatever message it is reading stored on the variable of can message. So we are just going to receive one message or two or three messages, so you can get it means you will store it here. That is not an issue. So after this for the printing purposes. After printing, you said this message ID is a 120 or not. Because here everything is printed, but we don't know what message ID is. So that we are checking the condition as a can message ID as a 120. If the ID number is 120 means you can check the first bit value. The first bit is 1 means you can set left indicator turn on. Okay, because the left indicator located on 5th bit, so 5th byte. So else if suppose this condition not satisfied means you can put the else if for the same one. Okay, so the second byte. So this is for unknown. The unknown is equal to 0 means our output is the right indicator. So now you can see where the right indicator located. So it is in the 4th bit. So sorry, 4th byte. So 4th byte means the value is 3. So 3 is 1, like that you can mention. For else the same like that for tail gate means you can add one more else if. So one more else if you can mention can message data of 2 is equal to 0 means you can find the low beam value. So the low beam we can. So the low beam is occurred on second wait. So you can mention that as a second wait.
This is right.
So once again I will explain this code from read set. So initially we are checked with only one variable. It is for only printing the values what are the message transmitted and received. So instead you have add one more variable with a different name. So previously you have added a can message. Instead I have added can message one as a new variable. And what is the board you are working based on the chip number you have selected. This void setup will not need to change anything. So please check it is a 500 kbps and then MCP 8 MHz or not. So after it's entered to the loop, so the same code for up to 4 loops no changes. It is for printing purposes. After printing the values, you can check this ID is 120 or not. Okay. So after checking that it is checking of the RKA. Let us check ID is RKA or not. Because if the ID is RKA means we can use some output, or else we can just ignore it. Okay. If the ID is 0x120 or not means you can check the first bit. So first bit for check lock signal. Lock signal enabled means you can turn on the this is for okay. So this is the else if concept. Suppose these values are no getting any values means you can give the else all the values are 0 or else you just don't want to give any else for also. Better you can mention the else part for all the values are 0 because once the values flash it means the value will be 1 only it will be showing so that I can mention here you can go for a 0 which means final else if you can put it as a else and make the ID values as a 0. Is there any doubt? Is it okay? Or else you don't need to give any printf statement also. This printf is for our understanding purpose. So what we receive here. So this here not println. These are all used for here what we need to print here. So this is these are no need. So we don't want means you can just comment this line also. So commented means you will get the code like. So what is the message you have read? After reading. You can just check in the condition of the ID number 120 or not. If it is 120, you can check it to the byte or byte to 0, byte to 1, byte to 2. If these bytes are not having go to any values means you can set this all the values are 0 for turn off, turn off, turn off.
If suppose another message ID I get to write this number, I don't know.
Sir?
If it is 120, not good.
Not 120 means it's just ignore it. It is not going to write any message. But now
Continuously it will read the values.
yes, sir, continuously reading.
After the suppose I am sending with ID of 20.
Okay.
Then continuously it won't go to the inside of that.
No, sir. It is checking that 120 also because that can message.
But nothing is not doing. ID is not like that. Any message we are not generating. Byte is first we told to correct all values.
Yeah.
Outside. We remove that one.
Oh, so this line the printf statements are.
You remove all this.
Yes. Because it is our requirement only. So based on our requirement, we can write this program. So now our condition is combination of that transmission of RK is u for that value the BCM going to respond it. So that is our requirement. So what are that output we need? We mentioned like that left indicator, right indicator, and then one more low beam lamp for that terminal. Okay.
What is 70 message? 0x70.
So 0x70 is a BCM message. Okay, I will mention here. And write it here. Okay. So from the line of 29 to 41 you can write it here. After sending message you can write this 5 minutes. 5 to 10 minutes. Yeah, we need to turn on the left indicator. Suppose the value is 0 means we need to set as a 0. That is what I mentioned. In the controllers we need to set both input and then output means true and false values. So that don't use the else if instead of using the else. So instead of using else we can use the else itself. So whatever you have turned it here, you can just copy and then paste it from that over RX7, mention the value as a 0. Okay? So instead of this else part, we just remove this else part here. So each, if you can give
So the CAN ID and the CAN details we can give out.
yes, there is not an issue.
So many lines it will have.
Yeah, so direction of lines you just to mention only.
And to send a message, CAN message at the end we can do directly.
Yes.
So only one line will be the remaining answers.
Yeah. So you can use 3 if and 3 else. So what you did in the before, you can give the directly opposite statement for the else. Which means nothing but you can mention that. So if we else for each byte, you can take the common ideas can message as the initially mentioned in the byte setup means there is not an issue, no need to mention it instead of else and if also. Yes, value range from 0 to 255. So and then I can use the outline, both falling and rising. Okay. So next one we add. Now that value will be increasing, decreasing. So based on that, my requirement is you all need to add 2 pages on progress bar, 2 indicators, 2 warning lamps, so 2 some indications based on that, seat belt, wipers, and fuel control. These kind of indications, some of the signals I will be listed here. You can extend the panel size. You will be able to extend the panel size from size for 800 or 1000. Height for 600 or 800 you can take it. So based on that you will allocate 2, which means 2 cages definitely need to add on it. So one for vehicle speed, another one for engine RPM. So one for progress bar, one for the left indicator, one for right indicator. So now this left indicator, right indicator we are working with green lamp. So warning lamp means we want a red color. So you can change the term as a red color for seat belt indication. So then give yellow color for wiper indication. Give blue color for high beam, low beam indications. So based on the colors also will vary. Okay. So now you understood how to design a cluster. So I will provide you the requirement. So what are the signals you can add it. Okay. So you are going to create the it means add these signals in our banana. So total 10 signals. For 2 or okay. So vehicle speed and engine RPM definitely you need to add as a cages only. So based on that you can set the value, increment values. So and then fuel values you definitely need to use this progress bar. So remaining things you don't need to work with the LED lamps only. So lamp color also we mentioned. Fuel level sensor. So you just search these signals in our database means you will get. Just type for left means you will get left indicator, right means right indicator, fuel level for fuel level sensor. That's a signal next to fuel level sensor. So next one vehicle speed, engine speed, and then seat belt status same, wiper also same, engine malfunction. Engine malfunction we can mention say engine MALF only. Malfunction here shorter mention as a MALF. High beam, low beam. Same.